Okay, so the product of powers property says that the product of two powers with the same base, that's important, they have to have the same base, equals the base raised to the sum of the exponents. So if you look at the example, when you are multiplying two exponents together that have the same base, for example, 6 to the power of 7 times 6 to the power of 4, you can simplify that by adding those exponents together. So that would be 6 to the power of 11 in that example. If you look at letter A, we have the example 3 to the power of 2 times 3 to the power of 5. So since those have the same base, you can add the exponent. So that would be 3 to the power of 2 plus 5, which is what?
3 to the power of 7.
3 to the power of 7. Since this is a numerical expression, we can go ahead and solve that. On your calculator, you can figure out that 3 to the power of 7 is what? 2,187. Good.
That's a big number.
In letter B, remember, you can only do this when the exponents have the same base. So for letter B, we can only combine 2 to the power of 4 with 2 to the power of negative 2, and 3 to the power of 4 with 3 to the power of 2. So again, you are adding the exponents. So 4 plus negative 2 is
2 to the power of
2. And 4 plus 2 is
3 to the power of 6.
good. So since this is numerical, we can go further. 2 to the power of 2 is 4. 3 to the power of 6 is 729. And 4 times 729 is 2,916. Very good.
Good job, Sean.
Okay, those are some numerical examples. Most of the examples that you'll see in this section are actually going to be involving variables like in letters C and D. So our goal when we're looking at these variable expressions is to just simplify as much as we possibly can. So we can use this property to simplify these expressions because we know that two powers with the same base that are being multiplied together, we can add the exponent. So in letter C, which variables can we combine? 3 and, the Q's, right. 3 plus 6 is 9. So that's Q to the power of 9 times R to the power of 2. And that's as much as we can do.
Can you write the alphabet?
Usually, you write them in alphabetical order. It's kind of just a guideline to go by. Okay, be careful on letter D.
Oh, can I? Well,
Go ahead.
so, n times n to the power of negative 4 times n, which is 3 minus 4 plus 1, which is
Good.
0. N to the power of 0 is 1.
That's exactly right. You notice an important thing is that the n by itself is really n to the power of 1, which means when you are adding the exponents, you do have to add the 1 as well. So this is 3 plus negative 4 plus 1, which is 0. And we learned on Tuesday that n to the power of 0 is 1. So the correct answer is 1. So pay attention to this box right here. It just goes over what we just said. It says a number or variable written without an exponent actually has an exponent of 1. Okay, that's the first property. The second property is called the power of a power property. In words, it says a power raised to another power equals that base raised to the product of the exponents. So when you have a power raised to another power, what we call a double power, okay, like in this example, 6 to the power of 7 to the power of 4, there's two exponents on that number. To simplify that, you can multiply those two exponents together. So in this example, 6 to the power of 7 to the power of 4 is equal to 6 to the power of 28 because 7 times 4 is 28. Okay, so in letter A, when you have a double power of 5 to the power of 2 to the power of 4, you're going to multiply those two powers together and you get 5 to the power of 8. 5 to the power of 8 is
390,600.
Very good. 390,625. Same thing in letter B. We see a double power, 4 to the power of 3, then to the power of 0. So we're going to multiply those exponents together. 3 times 0 is 0. 4 to the power of 0 is 1. In letter C and D, we're going back to the variables. And also in letter C and D, we're going to see that there's more than one property that we can actually apply to these expressions. So we're going to start with the double powers and get rid of the double powers first. So in letter C, we see that x to the power of 3 to the power of negative 5 has a double power. So I'm going to multiply those two powers or exponents together. So I get what? X to the power of negative 15 times x to the power of 4. Now I can keep going using the first product property that I learned, that when I'm multiplying two powers with the same base, what do I do with the exponents? Add them. So I get x to the power of negative 11. Now one of the most important things that you need to remember from our lesson on Tuesday is that you cannot leave an exponent negative. Your final answer should never have a negative exponent in it. Okay? So how do I remedy the negative exponent? What did we learn on Tuesday? How do I convert a negative exponent to a positive exponent?
Put it in the denominator. 1.
Put it in the denominator, in this case with a numerator of 1. So that would be 1 divided by x to the power of 11. Okay, letter D. Can someone volunteer to explain how to do this one? Rebecca?
So you would do you would do 3 times 4 because that's a double exponent.
Mm-hmm.
It would be a to the power 12.
Mm-hmm.
And then you would do negative 2 times 3 because that's double exponent. It would be to 6.
Good.
And then you would add those and it would be a to the 18th.
Very good. A to the 18th power. You don't have to do anything to that because it's already a positive exponent. Okay, the last property that we're going to learn today is called the power of a product property. Now this explanation they have there I think is a little bit confusing, so I'm going to do my best to explain it in another way. The power of a product property basically says that if your base of the exponent, if your base of the power is in parentheses, then the exponent applies to every factor inside the parentheses. So it's almost like the distribution property, except we're applying the exponent to everything inside the parentheses. So if you look at the example, inside the parentheses here are 2 times 4. So it's like they distributed the power of 3 to the 2 and to the 4 and got 2 to the power of 3 times 4 to the power of 3. Okay, so let's look at the first example. Letter A says negative 2y to the power of 2. Now the negative is outside the parentheses, okay, so we're just going to kind of ignore it for now. The power of 2, since this base is in parentheses, applies to both the 2 and to the y. Okay, so the negative sign, like I said, we're just going to leave it alone for now. This is like having negative 2 squared, or 2 squared times y squared. Okay, 2 squared is what?
4.
4. Y squared is just,
Y.
right, y squared. And that negative, again, just stays where it was. Okay, what do we notice different about B than letter A?
There's an exponent.
Right, there's already an existing exponent inside the parentheses. What else is in the parentheses now? The negative sign, okay? So remember, the exponent applies to everything inside the parentheses, okay? So we're going to apply the power of 2 to the negative 5 and to the t squared, okay? The negative is inside the parentheses this time. So it would be negative 5 in parentheses squared times t squared squared. So negative 5 squared is what?
25.
25.
No.
t to the power of 2 squared,
is t to the power of 4.
t to the power of 4. One of the most common mistakes I see on this type of problem is that since we're multiplying the exponents, students want to multiply the exponent times the whole number 2. So they would get like negative 10 for this problem. So remember, you're multiplying the exponents, not multiplying the numbers, okay? This is 5 to the power of 2, not 5 times 2, which is why we get 25 and not 10.
Why wouldn't the 2 on the outside, the second exponent, be a factor of 25? Yeah, that one.
Because it's outside the parentheses. Okay, letter C and letter D are both multi-step problems where we're going to apply more than one property in order to simplify. As we go through this chapter, the more practice we do, the more and more complex the problems are going to be. If you will work step by step, these problems are no harder than the one-step problems. Where we get in trouble is when we try to do too many things at once. Okay, so if you will take each problem step by step, they should be stay pretty simple. So let's look at letter C. The first thing we want to do is use this property to basically apply the power of 2 to the x to the 6th and y to the negative 3rd. Okay? So what do we get when we do that?
X to the power of 12 times y to the negative 6.
Good. X to the power of 12 times y to the power of negative 6. All I did was multiply 2 times 6 and 2 times negative 3. Now, I cannot have negatives in my final answer. So how am I going to get rid of the y to the negative 6?
1 over y to the power of 6.
Now combine those back together where x to the 12th is on the top and y to the 6th is on the bottom. And that's my final answer. Okay. So let's look at letter D. Jordan, what do you think I should do first in letter D?
Distribute the 4.
And what do you get when you do that?
X to the power of 8 times y to the power.
Very good. And Nia, what should I do next?
Distribute negative 4.
Okay. Oh, and what do I get? Sorry.
Yeah, negative 8 and then negative 4, which is negative 6.
Very good. Thank you. Charlotte, can you tell me what I do next?
You would put x to the negative 4 and y to the negative 16 in the denominator and put 1.
Okay, before I do that, there's something else I can do first. I see powers with the same base,
Oh, combine.
and I can combine them. Okay? So if I combine the x's, x to the 8th and x to the negative 8th, what can I do? What do I get?
Negative. 0.
Good. And then if I combine the y's, what do I get?
Negative.
So like we learned on Tuesday, x to the power of 0 is 1. And y to the power of negative 4 is
1 over y.
good. Okay, this last table on your notes is a really good resource for you. It kind of outlines basically what you need to know about simplifying expressions. All of these points won't apply until after tomorrow because we haven't learned how to deal with dividing exponents yet. But the two things I want you to focus on the most for today and today's homework are the first two. When your answer is in simplest form, you should never have any negative exponents, and you should never have any exponents with the same base. So focus on those two for now. We'll talk about the rest later. I'm going to put some practice problems up on the board. You can do these, you can continue to do these on your notes in the spare space. When you're finished with them, I want to take a look at them, and then I'll let you get started on your homework. Okay? So do me a favor and go ahead and write down all the problems first, and then I can put the homework on the board for as people finish. So.
Yes, one more.